Namaste dear students, welcome back to our channel. So today we have this year's ISI MSTAT papers problem, and this is the 10th problem from the subjective part. So this is a problem. It says that a city has n households which are numbered from 1 to n, and by y subscript I we denote the size of the ith household. Now a simple random sample. So this is important. SRS S1 of size m is drawn without replacement. Now this is a very important condition, that is the SRS sample is drawn without replacement, and it is drawn from the first m households. So actually basically we are partitioning the population into some subpopulations, and from each subpopulation we are drawing samples. So we are considering first m as one subpopulation and last m, that is from n minus m plus 1 to n, as the second subpopulation, and from that we are drawing S2, and that is also of size small m. We assume that small m is less than capital M, which is obvious, and also that m is greater than half of n. So that means there must be some overlap, right? So the first m and the last m will have some overlapping households or units. So we have to compute firstly the probability that an unit I is included in the sample S1 union S2, and this we have to do for I equal to 1 to n. Secondly, we have to show that T is an unbiased estimator of the average household size, but T is defined in this manner, that is the sum of yi divided by the inclusion probabilities for all i's or all units that are in the sample S1 or S2. So we have to show that this is an unbiased estimator of average household size. That means 1 over n summation yi, right? So we have to show that this is an unbiased estimator of this quantity. Okay, so first we start with the part A. Now note that we are drawing m samples from the first m observation and m from the last m observation, that is n minus m plus 1 to n. And since we have m greater than n by 2, we have this kind of a condition that this starting point of this unit is lying before this unit. So there is some overlap. Now the required probability can be expressed as I belonging to S1 union S2 as the union of two events AI and A1 and A2, where what is AJ? That is the ith household is contained in the jth sample Sj. So ith household is contained in S1 is denoted as A1, and ith household contained in S2 is denoted as A2. And by definition, this probability is a union of A1 and A2, and that is probability A1 plus probability A2 minus probability A1 intersection A2. So this is the form. Now, as you all know, that for individual samples, we can easily calculate these inclusion probabilities, right? So suppose we are computing probability I belonging to S1. That means the sample S1 of size small m contains a particular unit I. So that probability will be equal to the probability, or that probability will be equal to the ratio of number of cases which are favorable. Now that means we are actually including the ith household, and the rest of the small m minus 1 households are coming from capital M minus 1 many households. So capital M minus 1 choose small m minus 1. This is the number of ways we can choose small m minus 1 households, and taking the ith household already fixed in the sample. Okay, so that actually simplifies to small m by capital M, and this is very common. This is the inclusion probability for simple random sampling without replacement. Okay, I hope you all have seen this form. So this will be true if we are obtaining the probability for the first m unit. So there is non-zero probability of inclusion of the first m units, right? Because that is the subpopulation from where we are drawing it. But for the rest of the observations, it is obviously 0. Similarly, we can compute that for I belonging to S2, this will be 0 for the first n minus n units. But for the last m units, this will be similarly small m divided by capital M. Now the third term, that is little tricky. So here we have I belonging to intersection of two samples, that is like S1 and S2. So we have S1 and S2, and here we have the ith unit. So I is here. So we are fixing one unit that is common in both samples. So the rest of the small m minus 1 samples in S1 is coming from the capital M minus 1 many observations in the subpopulation, right? Similarly for the S2. So that means m minus 1 choose small m minus 1 square. So that is the number of ways to choose this kind of samples S1 and S2 where there is the ith unit included in both of them. That is the intersection set. So the probability will be m minus 1 to small m minus 1 divided by capital M to small m square. And this also simplifies to small m by capital M square. And this is true if we are selecting the unit in the intersection part, right? Otherwise, if we are seeing above m or below n minus m plus 1, there is no chance that a unit coming from these two regions are in both the samples S1 and S2 due to restrictions in the subpopulation. So combining this, we obtain probability I belonging to S1 union S2 as this. So this is the answer for the first part. For the second part, we have to show that this estimator T is an unbiased estimator of average household size. Now expectation of T, how it can be expressed? So we can actually write this using some indicators. So since we are using the sum in the set S1 union S2, suppose we define I sub I of S1 S2 as 1 if the ith unit is included in S1 union S2 and 0 otherwise. If we define it like this, then T can be expressed as the sum from 1 to n, the sum from 1 to n of this term multiplied by the indicator. And as you can understand, this will be 1 if I is in S1 union S2, this will be 0 if it is in the complement of S1 union S2, right? So this will be the case. Now if you just take expectation, the expectation will go inside, and the expectation of this is nothing but the probability that I is here in the union of S1 and S2. That is by definition pi I, so it is cancelled, and this is the expected value, that is the average population household size. Hence it is proved that this is an unbiased estimator for this quantity, right? So this is all about this video. I hope you enjoyed it, and I hope you all are enjoying other videos in this series as well. Please do consider sharing this video and other videos with those who are aspiring and those who are interested in this kind of problems or this kind of, this ISI MSTAT exams. And I hope you will enjoy upcoming videos in our channel as well. Keep on supporting us through your enthusiastic comments and likes and share. Till then, take care. Hare Krishna.